This is Bob Capetta from the University of Illinois at Chicago, and this lesson is Math 181 Final Exam Review, Part 3. Let's remind ourselves of the behavior of polar coordinates. If we have a point here, x, y, we can also think of it in polar form. R is the distance from the origin, theta is the angle measured from the x-axis. So what are the relationships we have between x, y, and r theta? Cosine of theta is x over r. So if that's the case, r times cosine of theta equals x. Similarly, sine of theta is y over r, opposite over hypotenuse. So r sine theta is y. Also, we have a right triangle here, so x squared plus y squared is r squared. And then regarding our angle, tangent is opposite over adjacent. The tangent of theta is y over x. So 1, 2, 3, 4 facts to know to convert between polar coordinates and Cartesian coordinates. So our question is to convert x squared plus y squared equals 4x to polar form. Well, what do we know? We know x squared plus y squared is r squared, and we know x is r cos theta. So making that substitution, we get r squared is 4r cos theta. We can divide both sides by r. R is not going to be 0 in this problem. To cause a problem, at least, we're going to get r is 4 cos theta. What does that graph look like? It's a circle. You could choose various values. For example, if theta is 0, cos of theta is 1, and r is 1 when theta is 0. When theta is pi over 3, cos of pi over 3 is a half. 4 times a half is 2. You can see r is 2 at 60 degrees here. You could plot some other points to convince yourself that indeed that's the graph. Our next question is to convert y equals root 3x to polar form. Recall, x is r cos theta and y is r sine theta. So making that substitution, y, r sine theta will equal root 3x, root 3 r cos theta. And if we divide by r, we get sine theta is root 3 cos theta. Dividing both sides by cos theta, sine theta over cos theta is root 3. And that, of course, is tangent of theta is cos 3. For what value theta is tangent root 3? I believe that is pi over 3. Sine of pi over 3 is root 3 over 2. Cos of pi over 3 is a half. So we get theta is pi over 2. What does that graph look like? Again, it is a line through the origin with a slope of square root of 3 over root 3 over 1. Our next question is to convert r equals 10 sine theta to Cartesian form. Well, we don't really have anything that looks obvious here, but if we decide to multiply both sides by r, then it becomes easy. Multiplying by r, we get r squared is 10r sine theta. R squared is x squared plus y squared. R sine theta is just y. So our equation becomes x squared plus y squared equals 10y. To see that graph, r equals 10 sine theta, or x squared plus y squared equals 10y. It is a circle that looks like this. Our next question is to convert r equals cosec theta to Cartesian form. Cosec theta is 1 over sine theta. Multiplying both sides by sine theta, we get r sine theta is 1. But what was r sine theta? R sine theta was y, so y equals 1. And that graph is just a line where y equals 1, horizontal line. Our next question is a challenging one. Integral from 0 to 1 of x squared e to the 2x dx. This is going to require integration by parts. I'm going to choose to ignore the endpoints until I'm finished taking the antiderivative. Reminding us of the integration by parts formula, integral of u dv is uv minus the integral of v du. So I've got the integral of x squared e to the 2x. We have to choose a u, we have to choose a dv. U is the easier thing to differentiate. U is x squared, dv is the one that's easy to integrate. dv will be e to the 2x dx. So if u is x squared, du dx, of course, is 2x, and du is 2x dx. So we're ready to use our u and our du in this formula up here. We have dv. I just need to get v. I do that by taking the integral of dv is the integral of e to the 2x dx. Integral of dv is v. To do the integral of e to the 2x, I need a substitution. So I'm going to let w equal 2x. The derivative of w with respect to x is 2. So dw is 2 dx. dw divided by 2 equals dx. This will become e to the w, dw divided by 2. This side integral of dv is just v. Pulling out the 1/2, v is 1/2 integral of e to the w dw. The integral of e to the w is, of course, just e to the w. And what is w? W is 2x. So we get v is 1/2 e to the 2x. So we have u, dv, du, and dv. We are ready to plug that in to find this antiderivative. We want uv, x squared, times 1/2 e to the 2x, minus the integral of v du, minus the integral of 1/2 e to the 2x, times 2x dx. Simplifying this a little bit, you'll notice the 1/2 times the 2 becomes 1, so this integral is just integral of x e to the 2x dx. This is x squared times e to the 2x over 2. So now we have to do integration by parts one more time. We've got to do the integral of x e to the 2x using integration by parts where u will be x and dv will be e to the 2x dx. So here's where we are. We're going to work on this integral, defining u and dv. And what will they be? U is x, dv is e to the 2x dx. Now we've already done this integral in the earlier problem, but du dx is 1, du is dx. Integral of dv is the integral of e to the 2x dx, which is e to the 2x over 2, or 1/2 e to the 2x. So we're ready to do this integral uv x times 1/2 e to the 2x, minus the integral of v du, minus the integral of v, 1/2 e to the 2x dx. We can pull that 1/2 out. This is x e to the 2x over 2. And then the integral of e to the 2x, again we've done multiple times, is 1/2 e to the 2x plus c, of course. So we have this piece just about finished. It's x e to the 2x over 2 minus, that's e to the 2x over 4 plus c. And I will substitute that up here for this integral. Better put it in parentheses to make sure there's no issues with this subtraction sign. So this is what we had on the previous slide. That was the result of our integral. Replace this whole thing here. And you'll notice I put it in parentheses. Remember to distribute the minus sign. Minus here, minus minus becomes plus. So the integral of x squared e to the 2x dx will be that. But remember we were doing a definite integral from 0 to 1. Which means I've got to take this part without the c, evaluate it at 0, evaluate it at 1, subtract. Plugging in 1, 1 e to the 2nd over 2 minus 1 e to the 2nd over 2, those go away, plus e to the 2nd over 4. Plugging in 0, this piece is 0, this piece is 0, that's e to the 0 over 4. So again, these first two things are exactly the same. 1 e squared over 2, they cancel. This first parentheses just gives me e squared over 4. This gives me e to the 0 over 4, which is 1 over 4. So my answer is e squared over 4 minus 1/4. Our next question is the integral from 0 to pi over 4 of cos 2x dx. This is going to require a U-substitution. I'm going to rewrite that to emphasize the fact that the endpoints are x goes from 0, x to pi over 4. I want u to be 2x. So the derivative of u with respect to x is 2. du is 2 dx. du divided by 2 is dx. So this becomes u, cos u. dx becomes du over 2. But the endpoints have to change. If x is 0, what is u? 2 times 0. If x is pi over 4, what is u? 2 times pi over 4. So we can pull the 1/2 out in front. 2 times 0 is 0. 2 times pi over 4 is pi over 2. So I get 1/2 the integral as u goes from 0 to pi over 2 now of cos u du. Integral of cos u is sine u. So we have 1/2 sine u evaluated from 0 to pi over 2, which is 1/2 sine pi over 2 minus sine 0. Sine pi over 2 is 1. Sine 0 is 0. 1/2 of 1 minus 0, which of course is just 1/2. Our next question is the integral of 13x minus 7 over 2x squared minus 7x minus 4. This is going to require partial fraction expansion. So we can factor this denominator, 2x squared minus 7x minus 4, into 2x plus 1 times x minus 4. We want to rewrite this fraction as a over 2x plus 1 plus b over x minus 4. Now remember how to add fractions. It'll be a times x minus 4 plus b times 2x plus 1 all over 2x plus 1 times x minus 4. Distributing ax minus 4a plus 2bx plus 2, that's the numerator. That's going to have to equal 13x minus 7 because the denominators are the same. So in a sense, I'm multiplying both sides by the common denominator, or you can think you're just ignoring them since the denominators are the same. So I will need 13x minus 7 will equal ax minus 4a plus 2bx plus b. And now the question comes into solving for a and b. So ax plus 2bx is a plus 2bx. That's got to be the same as 13x. Negative 4a plus b will have to be the same as negative 7. The coefficients of x have to be the same, and the constants have to be the same. So we have two equations and two unknowns. A plus 2b is 13. Negative 4a plus b is negative 7. I think I'm going to solve for b here. So b will be 4a minus 7. And then I'll plug that b in over there to solve for a. It'll be a plus 2 times 4a minus 7 equals 13. A plus 8a minus 14 is 13. Add 14 to both sides. A plus 8a, 9a is 27. And a is 3. And then we plug that 3 in up here to get b is 4 times 3 minus 7. B is 12 minus 7. B is 5. So we have rewritten 13x minus 7 over 2x plus 1x minus 4 to be a 3 over 2x plus 1 plus b plus 5 over x minus 4. So having a and b, rewriting our original question, we get this. So to integrate 13x minus 7 over 2x squared minus 7x minus 4, we will integrate 3 over 2x plus 1 plus negative 5 over x minus 4. To do that, we need some substitutions. U is 2x plus 1, so du dx is 2. Du is 2 dx. Du divided by 2 is dx. And I'm not sure what that is. We'll eliminate that one. And that's fixed. So u is 2x plus 1, du divided by 2 is dx. W will be x minus 4. So dw dx is 1, dw equals dx. Making our substitution, that'll be 3 over u, du over 2, negative 5 over w, dw. Pulling the 3 halves out in front, pulling the negative 5 out in front. 3 halves integral of 1 over u du minus 5 integral 1 over w dw. Integral of 1 over u is log absolute u. Integral of 1 over w is log absolute w. U is 2x plus 1. W is x minus 4. Also fixed. Integral of 1 over w is log w. Making the substitutions. U becomes 2x plus 1. W becomes x minus 4. And the solution is 3 halves natural log absolute 2x plus 1 minus 5 natural log x minus 4 plus c. Our last question is the integral of cosine squared of 5x dx. To do this, we're going to go ahead and use a double angle identity. Cos 2 theta is cos squared theta minus sine squared theta. Rewrite sine squared theta as 1 minus cos squared theta. Distribute the negative. Minus 1 plus cos squared theta. The right hand side, cos squared theta plus cos squared theta, 2 cos squared theta minus 1. Add 1 to both sides. 1 plus cos 2 theta is 2 cos squared theta. Divide by 2, a half plus a half cos 2 theta is cos squared theta. And then replace the theta with 5x. So cos squared theta is 1 plus cos 2 times 5x divided by 2. So cos squared 5x is a half plus a half cos 10x. And that's relatively easy to integrate. Integrate of a half dx, integral of a half cos 10x dx. Integral of a half is a half x. Pull the 1/2 out in front. And we have 1/2 integral of cos 10x dx. Do that with the substitution. Let u equal 10x, or in this case w is 10x. W is 10x. dw dx is 10. dw is 10 dx. dw divided by 10 equals dx. So we're going to get cos w, dw over 10. Pull the 1/10 out in front. That'll make that 1/20th integral of cos w. The integral of the cosine is a sine. So the integral of cos w dw would be sine w plus c. A half x plus 1/20th sine w plus c. What is w? W is 10x. And our final answer is 1/2 x plus 1/20th sine 10x plus c. And that will conclude this lesson.